Yo guys, this is the first video on telescoping. So the first thing you need to know on telescoping is the general form, where you have one equation and a second equation where they follow each other. Sorry, this is one. So they follow each other. This is r plus 1. So they are right after each other. If that's the case, you can apply telescoping. So when you apply telescoping, we first distribute this summation sign onto the two of these equations. So the first thing we have is r equals 1 n f at r minus sum r equals 1 and f at r plus 1. We distributed the summation sign, or sigma. The next thing to do is we open this up. We spread it open. The first term is going to be r equals 1. So if you put r equals 1 there, you're going to have f of 1. Second term is going to be f at 2. Next is going to be f at 3. And you're going to have more. Plus, let's try to see the ones at the end. You're going to have f of n minus 2, right? Let's add a 1 to that. F of n minus 1. Let's add another 1 to that. F of n. This is this one, and it has to end at n because our upper bound is n. And this is f at r. Let's do the second one. The second one, the first term is not going to be f at 1. Because if we put 1 here, it's going to be 1 plus 1, which is 2. So it's going to start at 2. The negative sign for that negative sign. It's going to start at 2. We're going to have f at 2 plus f at 3 plus more plus f at n minus 2. Let's check now. N plus 1. It's going to be f at n minus 1 plus f at n plus f at n plus 1. Right? Those are our last terms. Why is it n plus 1 here? Because if you put the upper bound in the place of r, you get n plus 1. Okay, what's happening here? This f at 2 is the same as this f at 2. This f at 3 is the same as this f at 3. That's the same as that. That's the same as that. That's the same as that. What do we have left? This guy and that guy. Because all of these guys are going to cancel out because of this negative sign right here. Since this is positive and this is negative, that's positive and that's negative. That's positive and that's negative. That's positive and that's negative. And they're all equal. That means they have to cancel out. That means we end up with f at 1 minus f at n plus 1. So that's the general form for telescoping. You have a series that has terms that are following each other. You open it up and you cancel all the terms that cancel out. You end up with the first term and the last term of the series, and that's your final answer. That's usually how it goes. Sometimes though, you can use another method that I'm going to show you guys for doing this step, because sometimes it's annoying to write everything out. So we can use changing the indexing to get the thing that we want, which is what one of your lecturers uses, which is what one of your lecturer does. Yeah, I don't know what I'm saying there. Which is what Boitumelo does. Let me just say that. The lecturer for algebra. Right. But I'm going to show you guys with questions now. This is a past paper question. It's question 14 of the problems bank I sent on the group. It was in one of the past papers. So let's do this one. Applying the same rules we applied there. So if we apply the same rules, we have to first distribute the summation sign. Let's distribute it. That's going to be sum up to n from r equals 1 of r plus 1 to squared minus sum up to n from r equals 1 r squared. Okay, the question is going to tell you guys to use telescoping, but if it doesn't, you can tell you have to use telescoping because there's a r plus 1 here and there's a r here, which means these two terms are following each other and they are the same because this is squared and this is squared. So you have to use telescoping here because it's the same series, but this is following that. So let's try to open it up. Let's see the first term of this guy. First term of this guy will be r is equal to 1, and that'll be 2, so that'll be 2 squared. Next will be 2 here, that gives us 3, so that's 3 squared. Next will be 3 there, that gives us 4 squared, and more. Plus, let's check n minus 2. If it's n minus 2 there, we'll have an n minus 2 plus 1, this one. Okay, let me show you guys what I'm doing. I'm saying if we substitute into r plus 1 all squared, if we substitute n minus 2 here, we have n minus 2 plus 1 all squared, which is n minus 1 all squared. So that's like the second to last term, third to last term, I think. So n minus 2, n minus 1, I mean. You don't have to be specific about these. You can just start with n minus 2 if you want and just go to finish where n is substituted here, and then you'll have the same thing. But I'm going to start with n minus 1. Okay? I'm starting with n minus 1. You don't have to start there. You can start with n minus 2. All squared. Plus, that's n minus, what's going to follow this? Just add a 1 here. It's going to be n only. The next term, you have to add a 1 here. If you add a 1 here, this is going to cancel with this 1, and you're going to end up with n only. And the last term, if you substitute n here exactly as it is, because that's the last term, it's going to be n plus 1. If you don't understand yet, don't worry. You just have to watch the video, watch me do this question, and then try to do it after. If you don't understand, you're going to understand over the next questions that we're going to do. You don't have to try to understand everything at once. You just have to see a lot of explanations of the same thing and try to do the questions. Okay, that's the first series, where n equals 1, n equals 2, n equals 3. R is equal to those things. R is n minus 2, R is n minus 1, R is n. Let's do the second one. R is 1. Well, R is 1, we'll have 1 squared. We need to have a negative in front because this whole thing is negative. We have 1 squared. Then, when R is 2, 2 squared. R is 3, 3 squared. Sorry. R is 4, 4 squared. Plus dot dot dot. Plus. By the end, we'll have something similar, where R is n minus, okay, let's start n minus 2. Where R is n minus 2, just have n minus 2 here, squared, plus where R is n minus 1, will just be n minus 1, because we just substitute everything exactly as it is here. It doesn't change, this one doesn't change. It's not complicated as this one. Squared, plus the last term, where R is just n. So we have n squared. Okay, so now you have these two things. They are doing essentially the same thing that was being done by the equation on the other page. This is a negative sign. It's going to multiply into all of this. If the negative sign multiplies into all of this, the 2 squared and the negative 2 squared are going to cancel out. The 3 squared and the negative 3 squared are going to cancel out. the 4 squared and the negative 4 squared are going to cancel out. So all of the things inside here are going to cancel out, except for the first one here and the last one there. Because you see, this ends at n, this ends at n, and this has an n there. So it can only cancel the terms before. And this starts at 1, this starts at 2. So this can only cancel terms from 2 onwards. It can't cancel 1. So what are we left with? Here we had an n plus 1 squared. Here we have a minus 1, because minus 1 squared is still minus 1. That's essentially our answer for this question. Okay, so now I'm going to try to do the same question, but I'm going to use a different method. I'm going to try to do the same question, but use a different method. Maybe it might be easier for others to understand that way. But I think this one is easy. So sum from r equals 1 to n of r plus 1 squared minus r squared. First do the same first step, which is splitting it up. So we have sum from r equals 1 up to n, r plus 1 all squared minus sum of r equals 1. I'm just copying this basically. Right. The first step of this is to understand that you need to have these looking similar. You need to have these looking similar. If you can make them look similar, you can easily cancel them out. But now they don't look similar. Whereas here, we saw that the 2 squared and the 2 squared looked exactly the same. The 3 squared and the 3 squared looked exactly the same, except with different signs. That's why they canceled out. We need to try to make that obvious in this notation. So the first thing I'm going to do is I'm going to say let s equals r plus 1. If s equals r plus 1, and I know that here I have an r equals 1. Okay, wait, let me show you why I'm saying s equals r plus 1. I want to substitute one value here. I want that value to be s. Because if I put that value here, that means I have s squared, and here I have r squared, which looks very similar. S is a dummy variable, and r is a dummy variable. So since I'm going to be substituting numbers here, substituting 1, 2, 3, and so on, s squared would be exactly the same as r squared. That's why I'm trying to get this r plus 1 to be defined as s. If that's the case, those are my cars outside, by the way. What those? Yeah, my friend's driving that one. Alright, so the r is 1. R is 1 from this. R is 1. Starts at 1. I want to change this to be written or indexed in terms of s. So if I want to do that, s is equal to r plus 1. So if r is 1, that means I can put 1 here. So s would be 1 plus 1, and s would be 2. Right? So s is 2, since r starts at 1, so s starts at 2. So if s starts at 2, that means we have s squared here, and s starts at 2. If s starts at 2, our upper bound has to change, because we've essentially shifted this r by 1 unit forward, and it became s equals 2. Our n also has to shift by 1 unit forward. It has to be n plus 1. That's why our n is going to change and become n plus 1. Now let's try to write this using this new indexing format. So we have sum, the r became s equals 2, the n became n plus 1, the r plus 1 became s, squared now minus sum up to n from r equals 1 of r squared. That's just this repeated exactly as it is. Can you see that these look very similar now? It's just that this has a term that's not in here, and this has a term that's not in here. Let's try to find that out. But first, I want you to confirm that this equation is the same as this. Let's try to confirm that these two sums are the same. The first value here would be at s equals 2. So you put 2 here, that's 2 squared. That's the first value, it's 4. The first value here at r equals 1, you put 1 here, that's 2. That's 2 squared, which is 4. So the first values are the same. Let's check the second values. If you put 3 now here, which is the next value, you have 3 squared, which is 9. You put the next value for this one would be r equals 2. So you put 2 there, that's 2 plus 1, which is 3. 3 squared is 9, which is the same as this one. So these two equations are the same. These two series are the same. This ends at n plus 1. Let's just confirm the end. So you just put n plus 1 here at the end, and you have n plus 1 all squared. For this one, you put n here in the place of r. You have n plus 1 all squared. So they are identical. They are the same. You haven't changed anything. This is exactly the same as that. Let's see what we can do with this. This starts at 2, but this starts at 1. So that means this has an extra term at the beginning where r equals 1. Because as soon as r equals 2, that means this and this are the same going forward. So let's get that term out. We are going to get that term out. R equals 1. We have 1 squared. And the negative sign here at the front. That's that term. The term at the beginning of this one. At r equals 2, we have 2 squared. And it's the same as s equals 2 because we have 2 squared. S equals 3. 3 squared, r equals 3, 3 squared, and so on. Now let's check the ends. The ends, we have n plus 1, we have n. I'm going slow. If you think I'm going too slow, you can skip along and try to get to the answer and get to the other questions. But I'm going to go faster as we go to the other questions. I'm trying to make sure everyone understands. Okay, so this one is at the end, and it has n plus 1. It ends at n plus 1. But this one ends at n. So this one has an extra term at n plus 1 that this one doesn't have. Let's get that term out. The term is n plus 1, and the terms are all squared. So that means it's squared. That's the last term of this guy. Let's write the remainder of these guys now, since we've taken out the first term of this guy and the last term of this guy. We remove the last term of this guy, so everything is the same except it ends at n now because we've taken out the n plus 1. S equals 2 s squared minus this guy. Everything is the same except for the r. We've taken out the 1, so it doesn't start at 1 anymore. It starts at 2. R equals 2. So if you like, you can do this instead so that it makes a bit more sense. We have the 1 from here, and then we start after the 1, which is 2. So this series is still the same as that. This series is still the same as that. Now this is negative, this is positive, and they are exactly the same because I told you it doesn't matter if it's r or s. As long as we start at 2, we end at n, and these series are identical. So these cancel out because you're subtracting them. Which means we end up with n plus 1 all squared minus 1. Quite slightly longer, actually. I think I'm going to do the next questions using this method for you guys' sake. maybe do at least one in this method again, but this seems very short. This is question 18 of the questions I sent on the problems bank on the group. Try to do this question and then come back to confirm if your answer is correct. You can pause the video, try to do it, and then come back to confirm if your answer is correct. So I'm going to be a bit faster on this one. We distribute this guy, the sum. So we have sum up to n r equals 1 of 1 over r plus 1 minus sum up to n of r equals 1 of 1 over r plus 2. Right? It's the same as this, just distributed. Now I'm going to open it up. First series is going to be from r is 1. It's going to be 1 over 2 plus where r is 2, 1 over 3, r is 4, 1 over 4. Abo, you get the idea. Plus, by the end, we are definitely going to have an n minus 2 somewhere, 1 over n minus 3 somewhere, 1 over, oh no, my bad, minus 1. It's been a while since I've done these. 1 over n, and then a 1 over n plus 1, right? Now let's do the second one. Negative into 1 over, if you put 1 here, you get a 3, plus 1 over 4, plus 1 over 5, plus dot dot dot, plus 1 over n minus 2, plus 1 over n minus 1, right? I'm just going to the next term. So the next term, I'm just going to add a 1 here. Next term, I'm going to add a 1 to the n. Next term, I'm going to add a 1 again. It's still not the same as this if you put an n here. So I'm going to add another 1. Right, now it is the same as this, because if you put an n here, it's just n plus 2. You do have to end at n plus 2. That's what that means. Now from what we have here, you can tell that the 1 over 3 is going to cancel with the 1 over 3, the 1 over 4 is going to cancel with the 1 over 4, and so on. You don't scratch the numbers out when you are like writing on your exam. You don't have to do that. And then that's going to cancel with that, this is going to cancel with that, this is going to cancel with that. I'm just scratching it so you guys see what's happening. Okay, so what do we have left? The first guy and the last guy. So that means we have a half minus 1 over n plus 2. That's your answer. That's your full answer for the question. Straightforward. I'd say this is slightly longer. So if you guys are complaining about telescoping, I think this is what you guys are talking about. If you are fine with the second method, just skip along the video. But I'm going to do the second method here. Try to move a bit quicker on it. So we have sum. So you could have done it this way or you could have done it this way. Not both. You're going to waste your time on the exam. R equals 1 and 1 by r plus 1 minus sum and r equals 1 by r plus 2. Right, this is this step, right, with the summation sign distributed. What do we want? We want these two guys to be similar. How do we make them similar? You have to make this look the same as this. So how do we do that? Check this guy, r plus 2. It can be written as r plus 1 plus 1. So if we can get a way to put this r plus 1 to be one term, we can get a something plus 1, which is the same as this, something plus 1. So let q equals r plus 1. Doesn't matter what alphabet you use, it's a dummy variable. Q equals this, right? Now we need to change these bounds as well to be in terms of q. We had r equals 1 here. That means our q has to be 1, this one, plus 1, which is 2. And our n has to change. We moved our lower bound by 1 unit forward. It's now 2, it was 1. So our n has to move by 1 unit forward too. It has to be n plus 1. Now let's write the full things. We have sum from n of up to n from r equals 1 of 1 over r plus 1 minus sum to n plus 1. Our upper bound is changed from q equals 2, 1 over what is r plus 2, it's q plus 1, right? R plus 2 is q plus 1. I don't know if I made that here, but that's what we are getting to through all of this, because q equals r plus 1. It's equal to this guy. So that becomes q plus 1 because it's the same as that guy. Now we have this. If there's like things I don't explain clearly and you guys think I should explain them more clearly, tell me on like WhatsApp, the group. If there's things I explain too much that I shouldn't, also say that on the group. Okay, this is what we have now. This starts at 2. That means this has an extra term at the beginning where r equals 1. Let's take that term out. Put r equals 1 here, you get 1 over 2. That's 1 over 2 plus, then the remainder of the sum is r equals 2, right? Now starting at 2 because you've removed the first term, n 1 over r plus 1 minus, check this one. This one is starting at the right number, 2, but it's ending at n plus 1, whereas this one is ending at n. So we need to deal with the n plus 1 term. Let's deal with that. We're going to have the last term. That's going to be the last term. So that's 1 over n plus 1 in the state of q. We're going to put n plus 1 plus 1. That's that last term. And then what's left over after we've removed the last term? What's going to be left over is sum up to n, because we've removed the last one, which was n plus 1. Q equals 2, 1 over q plus 1. Right, this is what we have. So we have the half there, plus this guy, sum r equals 2 to n, 1 over r plus 1. Distribute the negative sign. You have negative sum to n from q equals 2 of 1 over q plus 1 minus, this negative sign goes there as well, 1 over n plus 2. Right, now what do we have here? We have a half. This cancels with that because it's exactly the same. It's just that this is q, this is r, this is r, this is q. But again, I said these are dummy variables. So if the bounds are the same, 2 and n, 2 and n, and the equations are the same, 1 over r plus 1, 1 over r, or 1 over q plus 1, that means these two series are the same. So they cancel out. We have a negative 1 over n plus 2, which is what we already had here. Okay, a good rule to check if you're correct is to just come back to the equation, check, this one ends at r at n plus 2, right? So it's going to be negative 1 over n plus 2. So this one ends higher than this one because this one ends at n plus 1. So this guy's last term has to be in the answer, 1 over n plus 2. And it has to be negative because this guy is negative. So you take the last term of the larger guy and the first term of the smaller guy. Smaller guy's first term is going to be 1 plus 1, which is 1 over 2. This is going to be 1 over 2. That's why we have the 1 over 2. So essentially, you can get the final answer before you even do the question, but you have to do these steps to show the marker that you are a student who is respecting the rules and following, doing questions and stuff. This is the next question. This one is not on the document I sent because it's not a past paper question. I created this one just to show you guys how to deal with lins before I get to a slightly more complicated one for lins. Okay, let's do this one. For logarithms, you apply the logarithmic laws. Remember, there's a logarithm law that says log of a over b is equal to log of a minus log of b. This is the log law we have to use. Because remember, on all of the telescoping things we've done, it has to be a negative. There has to be a negative somewhere. We need to have a difference of something, or else we can't telescope it. So let's try to apply this. The logarithmic laws can give us the negative. So we have sum from r equals 1 up to n of ln r plus 1 over r. We apply this logarithmic law, denominator and numerator, denominator and numerator, denominator and numerator. That means we have sum r equals 1 up to n of ln r plus 1 at the top minus ln r. That's what we have. Now we have our negative. We smile. Now we distribute this guy. If we distribute that guy, we get sum from r equals 1 up to n of ln r plus 1 minus sum from r equals 1 up to n of ln r. This is what we have. I'm only going to do the short way for this one, not the long way. If you guys want the long way explained more, of course, say on WhatsApp. Anything you need, just say on WhatsApp and we'll see if you can get it done. So the short way, you open it up, you have, let's check the answer first, in fact, before we even start. From this ends at r plus 1. This ends at r. So this is larger. So if we put n here, our last term has to have an n plus 1 here. Our last term is going to have a ln n plus 1. Our first term, because this starts at r plus 1, but this starts at r. So this has a first term that this guy doesn't have. First term is where r is equal to 1. So that will be ln 1. Ln 1 is 0. So basically this is what it simplifies to. Our final answer has to be this. Let's continue here. Let's try the first series. Put 1 here, you get ln 2. Put 2, you get ln 3, ln 4, plus dot dot dot, plus, I'm gonna go ln n minus 1, ln n, ln n plus 1, minus the second series, ln 1 plus ln 2 plus ln 3 plus ln 4, beautiful handwriting, I know, plus dot 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 plus ln n minus 1 plus ln n. This one ends at n. because it's just ln of the value and the last value is n. We distribute the negative sign, you get that this becomes negative, and all of these become negative. So this cancels that guy. Remember, don't cancel on your test. I'm just trying to show you guys what happens. I'm not going to cancel on the next question. Okay, so what do we have left? That guy and this guy. So basically we have ln n plus 1 minus ln, you get the idea, 1. How do you find ln 1? Because I just told you that when I was trying to get this one, what value it is. Let's try take a bit of a detour here. If you know what ln 1 is and know why, you can just skip ahead. Ln 1. What does this mean? This means e to some exponent that I don't know, let me name it k, is equal to 1. That's the definition of this. So it means this is basically k. So k is this. Therefore, what should k be? What exponent would I have to put e to for me to get 1 as my answer? So we know that anything to the power of 0 gives us 1. So that means k equals 0 because e to the 0 equals 1. That's why ln 1 is equal to 0. Log, ln, whatever logarithmic base you have, log of 1 is equal to 0. So our answer is ln n plus 1. That means this whole thing is the same as ln n plus 1. Okay, let's go to another one. Let me help you out. The only thing that's going to change here compared to the other one is that now you're going to take the 2 to the front because that's another log law. The log law where you take the exponent and make it a coefficient. And then basically you're going to apply the same thing and get to the answer. But here you have a 99, you don't have an n, so you have to deal with the 99 instead of the n. So try to pause the video and try to do this question. Okay, I hope you tried it. If you didn't, that is also existence. Sum from r equals 1 to 99. This 2, we take it as a coefficient, log base 10 of r over r plus 1, right? That's a log law. You can always take exponents of the thing that is inside and put them as coefficients. Now, if you have a 2 here and a sum, you can always take the 2 out. You can always take a coefficient or a constant outside of the sum. That's another law of sums. It's a law of sums now, or sigma notation. You use that. You get the 2 to the front. So we have everything inside. We have sum, r equals 1, 99, log base 10, r by r plus 1. That's what we have. Let's go on. 2. Now let's apply the log law we had applied that side, this law. That means here we'll have sum r equals 1 up to 99 of log base r minus sum from r equals 1 up to 99 of log r plus 1 base 10. Then we close the bracket. Okay, once again, I'm gonna do the short method. If you want the longer way, this one, tell me on WhatsApp and I'll see if I can make a plan. I will probably make like a short video explaining it again with like 2 problems or something like that. I don't want to make anything you don't need though. Okay, so this is what we have. So we have 2 as the front guy. Let's open these series up. If we put 1 here, that's r equals 1 because it starts at 1. We're going to have log 1, which is 0. If we put 2 here, we're going to have log 2. So that's log base 10 of 2. Then we have log base 10 of 3. And more logs. Plus, near the end, we have log base 10 of n minus 1 plus log base 10 of n. It ends at, oh, not n, my bad. This time we know that n is 99. Should I force it? Nope. You guys get the idea. Here we have 99. That's our last term. It's 99. The term here, 98. Because we keep continuing. So 98. Before that would be 97 and so on. Then we have a negative into, and then we write this one. Where r is 1, we have log base 10 of 2. Where r is 2, log base 10 of 3 plus dot plus log base 10 of 98 plus log base 10 of 99. This one has r plus 1. So the last term will be 99 plus 1 inside of the log. That's log base 10 of 100. Because that's what 99 plus 1 is. It's 100. What happens here? This cancels that. This cancels that. All these bad boys cancel out in the middle until you have this bad boy and that bad boy. Which means you have 2 into, that's 0, doesn't matter. You have negative log base 10 of 100. Which means you have negative 2 log base 10 of 100. Okay, now I want you to show you, the answer here is 2 for this guy, and the answer is 4. If you get that, the answer is negative 4. The final answer is negative 4. Just skip a few seconds ahead. But I want to help the people who can't figure out what this is. So k equals log base 10 of 100. What is this saying? It's saying 10 to some exponent gives us 100. What is the exponent? That's what this question is asking. That's what log is asking. What is the exponent we have to raise 10 to get 100? So what exponent do we have to raise 10 to? 10 squared is 100. So that means k is 2. That's why here we have negative 2 into 2, which gives us negative 4. Right, that's what we have as our final answer to this whole question. Now we've got to do this one. Out of these are carefully selected to be different so that you guys learn as much as possible. This one is also not in your problems bank, but this one is question 13. It was in a past paper. That means this was in a past paper. This one was not. This one was. Okay, let's come to this one. Actually, this one is seemingly, I'm just realizing now. It's the same as this, crazy. But I'm gonna show you why it's the same. First, if you have something like this, and they say use telescoping, you have to remember your partial fractions, first block. So let's try to apply the partial fractions. How do you find the partial fractions of this? Let's first deal with this alone. Forget the summation sign for now. You have 1 over r plus 1, r plus 2. Okay, if that's the case, we can write this as a over r plus 1 plus b over r plus 2. They told us to use telescoping. That's why we're applying this, because we know in telescoping, we have to have two things that are being subtracted, and the two things should follow each other. So these are following each other because this is r plus 1. Right after r plus 1, you should have r plus 2. Now let's find it. That means we can write this as a into r plus 2 plus b into r plus 1, all divided by r plus 1, r plus 2. Okay, now we just need to equate this to 1. So a into r plus 2 plus b into r plus 1 equals 1. Multiply out the b's into the inside. You have the b's and the a's. AR plus 2a plus br. If you know how to find the partial fractions, you can find the partial fractions. If you do that, the equation will turn exactly into this one, I think. If it doesn't, then we'll see. But I think it turns into this one. If it does turn into this one, that means you already know how to find the final answer. So you can attempt it if you know how to find partial fractions. You just find the partial fractions and then do it exactly how we did this one. Plus b equals 1. This video is becoming a bit long, but it's fine. Group these guys, take out the r. So you have r into a plus b plus 2a plus b equals 1. We don't have an r here. That means we shouldn't have an r here. That means these need to be 0 to cancel out this r. So a plus b equals 0, which means a is equal to minus b. Now let's get this guy. If these are 0, that means 2a plus b equals 1. 2a plus b equals 1. A is equal to negative b. 2 equals minus b. I mean, yeah, that. Sometimes my tongue slips. So I substituted this into the place of a. This now becomes minus 2b plus b equals 1. We subtract these. This becomes minus b equals 1, which means b is equal to minus 1. And a is just a negative version of b, so a has to be positive 1. Now let's go build our thingy. This. That means we have 1 over r plus 1, r plus 2 is equal to a is 1 over r plus 1 minus b is minus 1. That's why I'm putting the minus 1 over r plus 2. Yep. If this is the same, that means the sum from r equals 1 up to n of 1 over r plus 1, r plus 2 should be equal to the sum from r equals 1 up to n of 1 over r plus 1 minus 1 over r plus 2. Right? They should be the same. Which means we can just evaluate this. So here, the main problem with this question was finding partial fractions, which means it's important for you guys to revise your block 1 stuff, because this was block 1 and you didn't learn in block 2. To find our answer here, I'm not going to do it. Why? Because we did exactly the same thing on the other question. What I'm going to do is I'm going to give you the final answer. So I want you guys to try to find the answer to this. So the final answer, in the way that I showed you guys how to find the final answer, this one starts at 1 here, which means 2 here, which is 1 over 2. This one starts after this, but it ends after this again. So it ends at 1 over, you put n there, n plus 2. That should be your final answer. But obviously don't try to skip to this. You have to follow the steps. You're a student. I am a second year student. Yes, I get to flex. Okay, let's go on. Now we have this one. Okay, this was on you guys' thing, on you guys' past question papers. It's question 17 on my problems bank that I sent you guys on the group. But the first thing is, they say show that this is equal to this. So they helped you out here on the question that was on the past paper. They tell you to show that this is equal to this. You should already be getting a hint, because 3 is after 4 is after 3, which means you get to use telescoping. So you use telescoping on this exactly the same way you would have done here, and you get your final answer. And then there's an extra question which says find the sum to infinity. Please try to do this question now. Pause the video, take out your exercise book and try to do it. Okay, because this video is getting long, I'm not gonna do it, sadly, because I know you guys are not gonna watch long videos. You know that you just have to prove this thing, so I don't have to do it. You just have to do it and see if it's the same, and it is going to be the same using partial fractions. And that way we use for this, you use the same way we used for these equations, but I'm gonna give you the answer. So the first one, since we know the partial fractions are like this, the first one has to be, you put 1 here on the smaller one. It's going to be 1 over 4. You put n on the larger one. It's going to be 1 over n plus 4. That should be your final answer. You guys do it and find this answer. Okay, this is what I can help you guys with. The sum to infinity. If they say find the sum to infinity of something you've already reduced into something like this, a shorter version of it that doesn't have sigma notation inside of it, this is what you do. You say you find the limit as n approaches 0, well, infinity I mean, of the sum, okay, of the partial sum, I guess. This is called a partial sum because it ends at n. It doesn't go to infinity, it ends at n. So it's part of it. So if you find the limit as n approaches infinity of the partial sum, which is Sn, that's what this is. You get the sum to infinity. It's equal to the sum to infinity from r equals 1 of 1 over r plus 3, r plus 4. Oh, sorry. Okay, now let's do it. We have limit as n approaches infinity of 1 over 4 minus 1 over n plus 4. And this doesn't change. We can distribute the limit sign, of course, to here and to there. The limit for this guy is just 1 over 4, doesn't change, minus the limit to this guy. Limit is n approaches infinity of 1 over n plus 4. 1 over 4 minus, let's check this guy. If n approaches infinity, n is growing very big. You can check this on a calculator. If you put like 9,000 here, you get something that's very close to 0. Put like 90,000, it gets even closer to 0. If you put like 1 million or 9 million, you get something that's very, very close to 0. So if that denominator keeps increasing and the numerator doesn't change, the value approaches 0. That's part of the limit laws. So minus 0, which means the sum to infinity is 1 over 4. Okay, that's what that is. Last question. It shouldn't be the last question. I guess let me see which one I should do. I was planning on doing this one, which is question 15, but I think you guys have the capacity to do this one if you've done the ones before, because it's essentially the same thing, opening it up and trying to find your thing. I guess sum to infinity of the thingy we can do. Yeah, we can do that. Sum to infinity of this. So let's just try to find the answers to this. It'll be the first one of this guy, which will be 1 over e, minus, with the nth one of this guy, 1 over e to the n plus 1. That's the thingy. So the sum to infinity should be the limit as n approaches infinity of 1 over e minus 1 over e to the n plus 1. Limit of this guy, e is a constant, it doesn't change, it's a number like 4 or 5 or 6 or anything, so it doesn't change, just remains that. But this guy, the limit as n approaches infinity, if we put something here, 1, we get a small number for e to the something, eh? But the more we increase n, the more we increase this n, that means this increases because it's the exponent of e, right? If we increase the powers of something, it gets larger. So this thing gets larger because 2 squared is 4, but 2 to the power of 3 is 8, so it gets bigger as the exponents increase. As it approaches infinity, this approaches infinity. The denominator is getting smaller, the denominator of this, which means this whole thing is approaching 0, because if the denominator is approaching infinity, the numerator, or the whole value, is approaching 0. So that's 0. So this is your final answer. That's question 15 on the questions bank. It was on a past question paper, definitely, because I took these directly from past question papers. This would have been the last one. Yeah, I'm gonna do this one. So they gave us all of this like stuff in a lot of words. They wrote a lot more words than I did. Question 16. I hated that, but who cares? If the lecturers can punish us. So they gave you this. They said the sum of this guy is equal to an plus b to the power of 4 plus c. You have to find a, you have to find b, you have to find c. But then they also gave you a hint. They said 4r cubed plus this is equal to this. Okay. If you don't understand how the question is phrased here, because I like paraphrased and summarized, go to question 16 of the questions bank on WhatsApp. You're gonna see how it's written on the questions bank, which is how it was written on the question paper. So essentially this is what we have. They gave a sum of 4r cubed plus 6r squared plus 4r plus 1. Oh, I forgot to say r equals 1 and n. Okay, this whole thing inside is equal to that, and we know that we have to have a negative sign and 2 things following each other to be able to apply telescoping. So we rather use this version of it. That's sum r to n from r equals 1 of r plus 1 to the 4th minus r to the 4th. Now we can do our first step of telescoping, which is distributing this guy. So we have sum n r equals 1 of r plus 1 to the 4th minus sum up to n r equals 1 of r to the 4th. Now we open this thing up. If r is 1, we have 2 to the 4th for this one. Then it's 3 to the 4th. There's 5 to the 4th, and so on. Plus, if r is 1, we have 1 to the 4th. Oh, no, my bad. let's finish this one up first. We have n minus 1 to the 4th plus n to the 4th plus n plus 1 to the 4th, has to be n plus 1, minus this one now, 1 squared, 1 to the 4th, plus 2 to the 4th, plus 3 to the 4th, plus 5 to the 4th, plus dot dot dot, plus n minus 1 to the 4th, plus n to the 4th. This one has to end at n to the 4th. Can't end at n plus 1. Now this guy cancels, they cancel, you're left with this and that, which is 1, but it's negative, plus n plus 1 to the 4th. Right, this question, I forgot to explain this, was trying to confuse you guys. It had a lot of words and like a lot of stuff about like, I don't know, history of humanity and stuff. But the main thing for you to notice is they said something about they said something about telescoping. Therefore, you use telescoping. Do what you know. Like, just do what you know. But if you do understand the words and do what you are told to do. Right, so let's write this neatly. Start with the positive version of the thing. Start with the positive thing, I mean. To the 4th minus 1. And they said that the sum of this guy was equal to this thing. So, and they said we should find A, B, and C. We have written it in this form now. So let's find our A, our B, and our C. Our A is the coefficient of n. That's 1. So therefore, A equals 1. Our B is this 1. So our B is also 1. Our C is the leftover one. It's negative 1. So our C is equal to negative 1. Right, that's the end of the video. I hope you guys understood stuff. If you need any other things, make sure to vote on the poll so that I can make that video for you guys next time. Good luck on your worst years of your life at vets.